The objective of this lesson is to compare fractions with unlike numerators and denominators that have the same number of pieces missing from each whole. In third grade, students compared fractions with different denominators, but the same numerator, such as unit fractions with a 1 in the numerator, and fractions with the same numerator like 2/12 and 2/5, by recognizing that 12ths pieces are smaller than fifths. So if there were 2 of each, 2/12 would be less than 2/5 because there are the same number of pieces in each, but the fifths are larger. They also compared fractions with different numerators but the same denominator, such as 4/10 and 8/10. In this case, they recognized the size of the pieces were the same, but 8/10 has more pieces, so 8/10 is greater than 4/10. Today, we will be using that background knowledge to reason about fractions. Let's begin by looking at 3/4 and 5/6. Which is larger? Let's draw a model for each of these fractions to support our thinking. Notice that each model is missing one piece. Rather than thinking about the pieces that are shaded in, let's think about the missing pieces. 1/4 is missing from one model and 1/6 from the other model. We know from third grade that 1/4 is larger than 1/6, so there is more missing from 3/4. This would help us determine 3/4 is less than 5/6. As your child draws models to justify their reasoning, make sure the picture supports their thinking but does not determine their thinking. For example, it is common for students to draw a picture and say that they can just see there is more shaded in one model. However, you'll want to encourage them to explain how they know that they are correct. Student models can be inaccurately drawn, making it easy for students to make incorrect comparisons, as in this model. It appears that 3/4 is about the same as 5/6, so based solely upon the picture, a child might say they are equal, which we know is not true. Let's look at another example, 11/12 and 5/6, and let's think about it like pizzas. We know that there is one piece missing from each pizza or whole. However, a pizza that is cut into 12 pieces, or 12ths, would have much smaller slices than the same pizza that is cut into 6 pieces. So if we compare the missing pieces, 1/12 is much smaller than 1/6, so there is less missing from the fraction 11/12. This means that 11/12 is greater than 5/6. Now take a look at this problem. Cameron and Harry are brothers. Every day they like to race to the school that is 1 mile away. After 5 minutes, Cameron was 8/10 of the way to school and Harry was 6/8 of the way to school. Who is closer to the school? This time, we'll use a number line to help illustrate our thinking. First, let's draw a number line for Cameron. He was 8/10 of the way to school, so we need to partition our number line into tenths and mark 8/10. Next, let's draw another number line for Harry. He was 6/8 of the way to school, so we will partition our number line into eighths and mark 6/8. Notice both are 2 jumps away from the whole, and we know that tenths are smaller than eighths, so there is a smaller portion missing from 8/10. You may need to help your child understand that the fraction with the smaller portion missing is the larger fraction. In this case, this means that 8/10 is greater than 6/8, so Cameron is closer to the school. The objective for this lesson was to compare fractions with unlike numerators and denominators that have the same number of pieces missing from each whole. We met this objective by using reasoning and using models to justify our thinking.